The Splice to 350 kc mil utility service lateral conductors and a 3/0 American wire gauge exterior mounted photovoltaic system conductor within the gutter spacing inside a 600 amp rated panel board. A listed product that may be suitable is the 3M Scotch lock electrical connector, model number UR2G. IPS. This product is designed for splicing multiple conductors, including those used in service entrance applications. It is suitable for splicing conductors of these sizes to 350 kc mil copper conductors and a 3/0 American wire gauge copper conductor. The model UR2G X connector is rated for use in 600 amp service equipment and is designed to be installed within the gutter space of a panel board. It meets the requirements of the National Electrical Code and is under ITER's laboratories listed. For installation, firstly, strip the insulation from the conductors to be spliced, leaving approximately 1/2 inch of bare wire exposed. Secondly, insert the conductors into the connector, ensuring that they are fully seated and aligned properly. Thirdly, tighten the screws on the connector to the recommended torque value as specified in the manufacturer's instructions. Fourthly, cover the splice connection with electrical tape or a heat shrink sleeve for insulation and protection. Always refer to the manufacturer's instructions and applicable codes for proper installation procedures. The use of the model UR2G X connector requires the panel board to have sufficient gutter space to accommodate the connector and the splice conductors. It is essential to ensure that the splice connection is securely made and meets all applicable electrical standards. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations to ensure safety and proper functioning. When dealing with service conductors and splicing within a panel board, adherence to these codes is paramount. Firstly, it's important to understand the ampacity requirements for the conductors. The ampacity of the conductors must be sufficient to carry the calculated load, as determined by NEC Article 220. This calculation involves considering the continuous and non-continuous loads served by the electrical system. For instance, if the load calculation determines that a 400 amp service is required, the service conductors must have an ampacity of at least 400 amps. Secondly, the NEC addresses the physical protection of conductors. Conductors must be protected from physical damage, which can be achieved through various means such as conduit, raceways, or other approved methods. When routing conductors within the panel board's gutter space, ensure they are properly supported and secured to prevent strain on the connections. Thirdly, the NEC specifies requirements for conductor terminations. Terminations must be made in a manner that ensures a reliable electrical connection. This includes using listed connectors and fittings that are suitable for the conductor size and material. When splicing conductors within the panel board, use the 3M Scotch lock UR2G X connector, which is designed for this purpose. Ensure that the connector is properly tightened to the manufacturer's recommended torque value. Fourthly, the NEC addresses the grounding and bonding requirements for electrical systems. Grounding and bonding are essential for safety, as they provide a low impedance path for fault current to return to the source, thereby tripping the circuit breaker or fuse and de-energizing the circuit. Ensure that the panel board is properly grounded to the grounding electrode system, as specified in NEC Article 250. Fifthly, the NEC provides guidelines for working space around electrical equipment. Adequate working space must be maintained around the panel board to allow for safe operation and maintenance. This includes sufficient headroom, width, and depth, as specified in NEC Section 110.26. Ensure that the panel board is accessible and that there are no obstructions that could impede access. Sixthly, the NEC requires that all electrical work be performed by qualified personnel. Only licensed electricians or qualified individuals should perform electrical work on service conductors and panel boards. These individuals have the training and experience necessary to perform the work safely and in accordance with the NEC. Seventhly, the NEC emphasizes the importance of proper labeling and identification. All circuits and equipment must be properly labeled to indicate their purpose and function. This includes labeling the service conductors, circuit breakers, and other components within the panel board. Proper labeling helps to prevent confusion and ensures that the electrical system can be safely operated and maintained. Eighthly, the NEC provides specific requirements for photovoltaic or PV systems. When integrating a PV system with the electrical grid, it is important to comply with these requirements to ensure safety and proper operation. This includes using listed equipment, such as inverters and disconnects, and following the NEC guidelines for wiring methods, overcurrent protection, and grounding. Ninthly, the NEC addresses the use of surge protection devices. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning or other transient events. The NEC requires the installation of SPD in certain applications such as dwelling units and critical facilities. Consider installing SPD to protect the panel board and the equipment it serves. Tenthly, the NEC is constantly evolving to address new technologies and safety concerns. It is important to stay up to date on the latest NEC requirements and to consult with a qualified electrician or electrical inspector if you have any questions. By following the NEC guidelines and using listed equipment, you can ensure that the splicing of service conductors within a panel board is performed safely and in accordance with applicable codes and standards. Remember to always prioritize safety and to consult with qualified professionals when performing electrical work. The selection of the appropriate splicing connector is crucial for ensuring a safe and reliable electrical connection within the panel board. The 3M Scotchlock UR2G X connector is a suitable choice due to its listed status and design for splicing multiple conductors, but it's essential to verify its compatibility with the specific conductors being spliced and the environmental conditions within the panel board. Firstly, consider the conductor material. The UR2G X connector is designed for use with copper conductors. If the service conductors are made of a different material, such as aluminum, a different connector that is specifically listed for use with that material must be selected. Splicing to similar metals can lead to corrosion and failure of the connection. Secondly, verify the conductor size range. The UR2G X connector is suitable for splicing two 350 kcmil copper conductors and a 3/0 American wire gauge copper conductor. Ensure that the actual conductor size is being spliced fall within the specified range of the connector. Using a connector with an incorrect size range can result in a loose or unreliable connection. Thirdly, assess the environmental conditions. The interior of a panel board can be subject to temperature fluctuations and humidity. Ensure that the splicing connector is rated for use in the anticipated environmental conditions. If the panel board is located in a damp or corrosive environment, a connector with a high degree of environmental protection may be required. Fourthly, check the voltage and current ratings. The UR2G X connector is rated for use in 600 amp service equipment. Verify that this rating is sufficient for the actual voltage and current levels present in the service conductors. Using a connector with an insufficient rating can lead to overheating and failure of the connection. Fifthly, consider the ease of installation. The UR2G X connector is designed to be relatively easy to install, but it's important to follow the manufacturer's instructions carefully. Ensure that the conductors are properly stripped, inserted into the connector, and tightened to the recommended torque value. A properly installed connector will provide a secure and reliable connection. Sixthly, evaluate the available space within the panel board. The UR2G X connector requires a certain amount of space within the panel board's gutter space. Ensure that there is sufficient room to accommodate the connector and the splice conductors without overcrowding or obstructing other components. Overcrowding can lead to overheating and difficulty in performing maintenance. Seventhly, consider the long-term reliability of the connection. The UR2G X connector is designed to provide a long-lasting and reliable connection, but it's important to perform periodic inspections to ensure that the connection remains secure and free from corrosion. Check the tightness of the connector screws and the condition of the insulation. Eighthly, ensure compliance with the National Electrical Code. The NEC provides specific requirements for splicing conductors, including the use of listed connectors and proper installation techniques. Ensure that the selected splicing connector and the installation methods comply with all applicable NEC requirements. Ninthly, consult with a qualified electrician. If you are unsure about the proper splicing connector to use or the correct installation procedures, consult with a qualified electrician. A qualified electrician can assess the specific requirements of the electrical system and recommend the most appropriate splicing connector and installation methods. Tenthly, document the splicing connection. Keep a record of the splicing connection, including the type of connector used, the conductor sizes, and the date of installation. This documentation can be helpful for future maintenance and troubleshooting. By carefully considering these factors and selecting the appropriate splicing connector, you can ensure a safe and reliable electrical connection within the panel board. Remember to always prioritize safety and to consult with qualified professionals when performing electrical work. Proper torque is critical to ensure a safe and reliable electrical connection when using the 3M Scotchlock UR2G, X connector or any similar splicing connector. Torque refers to the rotational force applied when tightening a screw or bolt. Applying the correct torque is essential for achieving the proper clamping force between the connector and the conductors. Insufficient torque can result in a loose connection, while excessive torque can damage the connector or the conductors. Firstly, understand the manufacturer's recommendations. The manufacturer of the splicing connector, such as 3M for the UR2G, X connector, provides specific torque recommendations for their products. These recommendations are typically found in a product's installation instructions or technical specifications. Always consult these instructions and follow the recommended torque values. Secondly, use a calibrated torque wrench. A torque wrench is a specialized tool that allows you to apply a precise amount of torque to a fastener. It is essential to use a calibrated torque wrench to ensure that you are applying the correct torque. Calibrated torque wrenches should be periodically checked and recalibrated to maintain their accuracy. Thirdly, apply the torque gradually. When tightening the connector screws, apply the torque gradually and evenly. Avoid applying the full torque value all at once, as this can damage the connector or the conductors. Instead, tighten the screws in small increments, checking the torque value after each increment. Fourthly, follow a tightening sequence. If the connector has multiple screws, follow a specific tightening sequence to ensure that the clamping force is evenly distributed across the conductors. The tightening sequence is typically specified in the manufacturer's instructions. A common sequence is to tighten the screws in a crisscross pattern. Fifthly, avoid over-tightening. Over-tightening the connector screws can damage the connector or the conductors. It can also cause the connector to deform, which can reduce its clamping force and lead to a loose connection. If you accidentally over-tighten a screw, loosen it and retighten it to the correct torque value. Sixthly, check the torque after installation. After the connector has been installed, check the torque of the screws to ensure that they are still within the recommended range. Vibration, temperature changes, and other factors can cause the screws to loosen over time. Periodic torque checks can help to prevent loose connections. Seventhly, consider the conductor material. The recommended torque value can vary depending on the conductor material. For example, aluminum conductors typically require lower torque values than copper conductors. Ensure that you are using the correct torque value for the specific conductor material being spliced. Eighthly, use anti-seize compound. Applying a small amount of anti-seize compound to the connector screws can help to prevent corrosion and make it easier to tighten the screws. However, be careful not to use too much anti-seize compound, as this can reduce the friction between the screw and the connector and lead to over-tightening. Ninthly, consult with a qualified electrician. If you are unsure about the correct torque value or tightening procedures, consult with a qualified electrician. A qualified electrician can provide guidance and ensure that the splicing connection is properly torqued. Tenthly, document the torque values. Keep a record of the torque values used for each splicing connection. This documentation can be helpful for future maintenance and troubleshooting. By following these guidelines and applying the correct torque, you can ensure a safe and reliable electrical connection when using the 3M Scotchlock UR2G X connector or any similar splicing connector. Remember to always prioritize safety and to consult with qualified professionals when performing electrical work. Gutter space within an electrical panel board refers to the open area surrounding the internal components, providing room for routing and managing conductors. Sufficient gutter space is crucial for safe and compliant electrical installations, especially when splicing conductors. Firstly, NEC requirements for gutter space. The National Electrical Code, or NEC, sets specific requirements for gutter space in electrical enclosures, including panel boards. These requirements are outlined in NEC Section 312.8, which specifies the minimum dimensions for wire bending space at terminals and minimum gutter space for conductors entering or leaving the enclosure. Secondly, calculating required gutter space. The amount of gutter space required depends on several factors, including the size and number of conductors, the voltage of the system, and the type of enclosure. NEC Table 312.6 provides guidance on the minimum wire bending space at terminals, while NEC Section 312.8 provides specific requirements for gutter space. Thirdly, conductor fill limitations. The NEC also limits the amount of conductors that can be installed in a raceway or enclosure, including the gutter space of a panel board. These limitations are outlined in NEC Chapter 9, which provides tables and calculations for determining the maximum number of conductors allowed in a given raceway or enclosure. Fourthly, impact of insufficient gutter space. Insufficient gutter space can lead to several problems, including difficulty in routing and terminating conductors, increased risk of conductor damage, overheating, and difficulty in performing maintenance. It can also violate NEC requirements, which can result in code violations and safety hazards. Fifthly, considerations for splicing. When splicing conductors within the gutter space of a panel board, it's important to consider the additional space required for the splicing connectors and the splice conductors. The splicing connectors should be listed for use in the gutter space and should be installed in accordance with the manufacturer's instructions. Sixthly, selecting a panel board with adequate gutter space. When selecting a panel board, it's important to choose a model with sufficient gutter space to accommodate the anticipated number of conductors and splices. Consider the future needs of the electrical system and select a panel board with extra gutter space to allow for future expansion. Seventhly, proper conductor routing. Proper conductor routing is essential for maximizing the available gutter space. Route the conductors in a neat and organized manner, avoiding unnecessary bends and crossovers. Use cable ties or other means to secure the conductors and keep them from obstructing other components. Eighthly, avoiding overcrowding. Overcrowding the gutter space can lead to overheating and difficulty in performing maintenance. Avoid packing too many conductors into the gutter space and ensure that there is adequate ventilation to prevent overheating. Ninthly, inspection and maintenance. Regularly inspect the gutter space to ensure that it remains free from obstructions and that the conductors are properly routed and secured. Clean the gutter space periodically to remove dust, dirt, and debris. Tenthly, consulting with a qualified electrician. If you are unsure about the adequacy of the gutter space in a panel board or the proper methods for routing and splicing conductors, consult with a qualified electrician. A qualified electrician can assess the specific requirements of the electrical system and provide guidance on how to ensure a safe and compliant installation. By understanding the NEC requirements for gutter space and following best practices for conductor routing and management, you can ensure a safe and reliable electrical installation. Remember to always prioritize safety and to consult with qualified professionals when performing electrical work.